No worries. Thank you for asking, because that is a clarification for everyone. And the other thing that is confusing for everyone is this idea that MCPS has instituted a 50% rule where all assignments that are, have not been turned in or are missing are showing as 50%. So when you see a 50% score, typically that means that I have either not graded the assignment, possibly it was turned late, but right now in COVID, that is not really mattering. What it means ideally is that you need to get your assignment in. If you have turned in your assignment and it is showing a 50, that means I probably have not graded it yet. Please, everyone, I had a teacher-student meeting, teacher-parent meeting. We have a fair amount of students in our class that are in danger of failing. So I have sent progress reports to everyone and their parents about what your grades are, what is missing. I have sent individual notes to people that are in danger of failing, asking to please get some vocabulary assignments in, get a project in. These are not terribly difficult. Dream up an invention that saves time by tenfold. My dream was giant skyscrapers. What if you could clean the windows 10 times as quickly? I'm going to read some of the ideas that students have come up with because some of them are really cool. Some of them are great ideas. This is how invention happens. This is how innovation happens. You sit around and try and dream up something cool. Remember, for this assignment, you are a technology designer. You do not need to worry how this incredible invention is going to be realized in reality. You are just imagining the coolest thing you can imagine that is going to save a bunch of time in a process. Some things like the most popular is building a building 10 times as fast. What would it take? How would that impact us? So those assignments I feel are not that difficult and that you can get them in. That's 20 points. A vocabulary is 10 points. If I can get 4 vocabulary assignments from you, you will not fail. Those you should be able to do that in an hour. If it takes you 15 minutes to look up the words that are in the top of an assignment, that's trouble. So get these in, get your grades up, please. We're not quite sure who this is. We have a potential rogue entrant, number 29213. Let's see who the heck it is. Okay, who is that has 29213? Who got their name revoked? I can look. Oh. Somebody's got the moniker 29213 at MCPS for their name. I'm just wondering who that is. Anybody? All right, well, they don't seem to be making a disturbance.
Hello?
Hi.
I sent you this is Niaza.
Oh, hi. Perfect. No, I remember from last time. Sorry, I couldn't remember. Weird number. Perfect. Okay. I'm thinking this is probably about as good as we're getting. So let me go back over. We're finishing up our presentation on systems and universal system model. We'll hopefully have a little time at the end to work on our assignment on components of a system. The warm-up is due. The Unit 2 impacts of technology and constraints is due. So that is the one, dream up some invention that's going to do some task 10 times as fast. It currently takes 10 hours and it will only take an hour for you. This is supposed to be fun. This is supposed to be engaging. I want to read some of the responses because I think some people really got into the swing of it. we're using our imagination, we're innovating, we're inventing, but we're doing it in our mind. There's no restrictions on what we can do when we're thinking up a situation. The question is, how do you think up what the benefits of that invention will be, and how do you think about the costs? And don't think about it as costs or benefits to the product's marketing campaign. These are costs or benefits to us as a society. So things like pollution, loss of jobs, it's going to take a long time. It's going to be very expensive to make. Those are all good considerations. The idea, that, oh, if we get bad advertising, it might get a bad reputation. That's not as much of an impact as I'm hoping to get. Okay, so let's look at our warm up and get this party started. All right, hang on, let me stop sharing for a moment. Get back into my fabulous screen. And let's see. No, that's not it. Where is my warm up? Okay. All right. Oh, I know what I need. Uh-oh, and my phone is about to die, so our special caller might find him. I'm getting my fabulous calling thing. We're letting, oh, look, there's Dream. Get into period 8. Oop. All right. So, oh, no, help. How am I in the rhyme in the wrong warm-up? That's no good. I am so sorry. This is the wrong course. Let's go to this course. You do not need to know your variables, but what you do need to know is about open and closed loop systems. Okay, there's Jackson. Welcome. Okay, so which system has feedback? A closed loop system or an open loop system? Well, I'm going to call on someone. We'll see what happens. Emir, you're here. I saw you. What do you think? Which system has feedback? Is it closed loop or an open loop system? Amir via direct. Go ahead.
Closed.
Closed. Closed system has feedback. That is correct. Brilliant. Okay, so an open loop system is something like the water tap in your house. It's very simple. It doesn't take much to maintain it. It's just a valve that you open or you close, but the valve is not going to open and close by itself. A closed loop system has some form of feedback in it, like your thermostat in your home. When the temperature gets above 70 degrees, it stops heating. When it drops down below 70 degrees, it starts heating again. It automatically does it. I do not need to get up out of my bed to turn on the heat in the middle of the night because it's starting to feel a little cold. All right, so great answer. Question number 2, let's see. My friend Schnell. If your TV, is your TV a closed loop or an open loop system?
I feel like it's an open loop.
Okay, I believe that is correct. What's interesting with a TV, again, a lot of these, I've never thought about them as whether they are or aren't. So you need to sort of think your way through it. And this is like systems thinking. We're thinking about all the different pieces of this system. How does it work? So a TV does have a fair amount of feedback in it, right? Sometimes, my TV, it will dim or get brighter depending on the conditions in the room. It automatically tunes the channel in just right. But what makes it an open loop system? Why does it have to be an open loop? That's because there is nothing that turns my TV on or turns it off automatically, when I'm done with it. So an example of this would be, vaguely like the lights in your school, probably. A lot of light switches these days have a feedback mechanism in there. They have a little light sensor. And this is so that they will turn the lights off if nobody has been in the room for 20 minutes. Or typically it's if no one has moved inside the room, because I'm sitting at my desk working away and all of a sudden the lights go out. So that's an energy saving device, but that turns a light from an open loop system into a closed loop system because it has feedback. It is, it's the idea that it would need to automatically turn the light on when I entered the room and turn it off when I left the room. So if my TV had a switch like that when I walked into the room, it turned itself on. When I walked out of the room, it turned itself off. That would make it a closed loop system. Like normal, I have to hit the button on the remote or on the TV to actually turn it on or turn it off. It's doing a lot in between. All right. So that is our warm up. Let's get into our presentation, let's do the presentation, and then I want to go through a few of the ideas. Not that one, this one. All right. Let's get to where we were. I'm pretty sure we stopped right about here. Okay, is everyone seeing this full screen?
Yeah.
There's Niaza. Okay, so last thing we were talking about was the idea of cruise control. Cruise control, in theory, is a subsystem of your car that automatically keeps your car driving at the same speed. The tricky thing with cruise control is that idea that I was saying, it doesn't affect brakes. Cruise control only affects the accelerator. It stopped, so that if I can still get a ticket for going too fast, if the speed limit is 30, I have my car set at 30, but I hit a big hill right where the camera is. It is not going to slow my car down going downhill, actively slow the car down by using the brakes when I'm on cruise control. It will not be giving it any gas. I'll be coasting down the hill, but I could coast faster than 30 miles an hour. Okay, when we started this conversation, a farm is one of the things I thought about as a system. A farm is an integrated system of both living, the farmer, the crops, animals, weeds, insects, and non-living, the tractor, barn, house, machinery, fertilizer, and subsystems. The tractor and the farm itself are an open system because they need fuel and maintenance from outside sources in order to function. So this is saying a tractor, like your car, needs you to turn it on. It does not turn itself on for you as you approach it and turn itself off as you walk away. The gasoline, also an open system, very similar to just the water tap in your house. It's got a trigger that opens the valve and closes the valve. That's basically it. Same thing on a tanker truck. It's just a lot bigger, the way that they're filling the tank. System thinking applies logic and creativity with appropriate compromises in complex real-life problems. It uses simulation and mathematical modeling to identify conflicting considerations before the entire system is developed. Let me read through this one more time. Systems thinking applies logic and creativity with appropriate compromises in complex real-life problems. So system thinking is about real-life problems. It uses simulation and mathematical modeling to identify conflicting considerations before the entire system is developed. So I was saying before that I have a PMP certification. That is Project Management Professional. I can run big projects. When I am running a big project, one of my main tasks is to break every single task down into its component parts. What is the smallest level of this task that needs to be accomplished? I organize those, I orchestrate how they are going to go back together, and the timing of that is essential. Every step needs to dovetail with the next
Walk
step.
around the mess, Noah.
Hmm?
Walk around.
Okay, well, you might want to mute yourself.
Sorry.
No worries. If that's the worst thing that happens, we'll be just fine. But when I am doing that work, when I am trying to calculate how long a process is going to take, when do I need to schedule the team of electricians to put the wiring in the pipes in my foundation if I need to create the foundation first? I use simulation and mathematical modeling to see how long it should take me to get that foundation built. I have numbers, I have figures from previous builds that I can use to estimate the time it will take to do this build. I am using those tools to try and think of every eventuality for my system. One of the other big tasks that I have as a project manager is risk assessment. Risk assessment means, like, particularly if I'm building Foxconn's new factory in Wisconsin, this is a $500 million project. It is $500 million. So there is a lot of money riding on this project and it being delivered on time. What do I need to do to ensure that every step happens as predicted, or that I have a contingency plan if something goes wrong? I also spend time at the start with my team, literally dreaming up every single thing that could possibly go wrong with our project. Is there a hurricane? What about torrential flooding? What about a fire? What about an earthquake? You need to take all these eventualities into account and create plans to address the situations. That way, when they happen, you already have a plan to work with. All right? Analyzing a system is done in terms of its individual parts or in terms of the whole system, how it interacts with or relates to the other systems, For example, discussing a computer system may involve the particular parts of a single computer, or it may include the entire computer network. In contrast, discussing the solar system may involve listing the planets, stars, and other celestial bodies, or it may be discussed by comparing our solar system to other solar systems in the universe. So all this is saying is sometimes with a system, you are looking at the parts, the individual pieces of the system, and sometimes you're looking at the system as the whole, that it is just a system like our solar system, okay? Systems also appear in many aspects of our daily life, such as solar systems, political systems, civil systems, and technological systems. What about school systems? There's certainly a school system that we're a member of. I love the complexity of this bridge down here. So systems are all around us. Environmental systems. Okay, the universal systems model can be defined as a general conceptualization on how a process can be represented. Okay, There are 4 basic elements to the systems model. 1 is input, 2 is process, 3 is output, 4 is feedback. Systems can be either open loop or closed loop. So the universal systems model, there are 4 basic elements. These are what are on top of our assignment sheet for our closed and open loop systems. It's asking you, what is the input? What is the process? What is the output? What is the feedback? Is there feedback? Okay, they can be either open or closed loop. This is just a flow chart showing the process. So we start with input. Input, let's think of my gas stove, right? That's an open loop system. The input is gas from the county. The process is that I turn a knob which activates an igniter and releases the gas. The gas is ignited and I am generating light and heat from my gas, right? Those are my outputs. I actually get some light from the gas being lit, but I get heat from it. That is why I have a stove, so that I can heat things. Now there is feedback from the burner back to the input. So if I, a human, am the feedback, I'm seeing, is this flame big enough for what I need? I need to boil water. Maybe I should reduce the flame a little. I'm making rice and I just want it to simmer. I am the one looking at the flame and deciding how it needs to change. So I'm going back to my knob and I am adjusting my knob to adjust the output. I believe that strange sound is my dog. Okay, here's a good one. This will make sense to you. Universal systems model. Our goal is to make a pizza. What are the inputs? We've got dough, sauce, cheese, pepperoni, garlic, time, money, work. Other things than just the ingredients go into it. Somebody has to put them together. It takes time. Somebody has to buy these. The process. So the input for a pizza is the ingredients. The process is you preheat the oven, you roll out the dough, or toss it, shred the cheese, chop the garlic, add the toppings. I'm afraid they did not include sauce. Oh, there is sauce, but they never told us to put it on the pizza. Add toppings, place the pizza in the oven, oven cooks pizza, take pizza out of oven, and your output is hot pizza. So what's interesting is they're saying the feedback, and this is human feedback, because an oven is an open loop system. Pizza was burned. Take the pizza out of the oven sooner. Person needs to do that. Dough is soggy. Leave pizza in oven longer. Those are modifications to the process. Too expensive. Try cheaper ingredients. That's affecting your input. Don't like the garlic. Leave it out. That's an input. All right. So that is the universal systems model looking at how to make a pizza. This is a light bulb. All right. So our goal is to light the room so we can see well, but not waste energy. Our input is electricity. The process is the switch or the dimmer needing to be turned and lighting an electric light bulb. Okay, so if we're talking about a light bulb example, typically the switch is not so much part of the process as the light bulb actually lighting up. That is a tungsten filament is being heated with electricity to generate what outputs? Can anyone tell me? Jackson Blanco Prudencia, can you tell me what the outputs of this system are? Jackson? He's probably stepped away or has us muted. Jackson? Okay. This is something to remember when you're writing down outputs. So a lot of people would say the output of an electric light bulb is light, which is correct. But typically, anytime you are generating something like light or using a machine, you are also generating heat as a result. Usually a light bulb is not 100% efficient. All that electricity does not translate into light. A lot of the electricity is translated into the heat of the element of the light bulb. With an LED, I don't think there is any heat. So then we have our feedback is, do we have the light level right? We make observations and measurements. Then we correct it. If my light had a dimmer, I could make it a little less or a little bright, a little dimmer or a little brighter. I have a dimmer on almost all of my lights in my house now because LED lights are much brighter than their tungsten counterparts. So I find when I put LED light bulbs in my house, it is too bright. So I put dimmers in so I can reduce it a little and make it the light that I like. Okay? So feedback is allowing for control and correction of our input. All right? Feedback measures the output and then makes a control correction to the input. Okay, what resources are used during the process? During the process, the 7 technological resources are used. People, money, time, information, energy, materials, tools, and machines are all used in this process. Okay, we're almost done. So this is the idea of a human as the feedback mechanism. This is driving a car. So our command input is that we want to go 30 miles an hour. How to adjust that is the person puts their foot on the gas pedal and gets it going 30 miles an hour. We are driving a car. A car is made out of our 7 resources. People, information, materials, tools and machines, energy, capital, and time all went into the fabrication of this car, right? So I drive the car at 30 miles an hour, and my output is the speed of the car. I have an actual speed of 30 miles an hour. The feedback is me, the human, looking at the speedometer and making adjustments with my foot on the gas pedal to keep me at 30 miles an hour. So I am an active feedback system, but I am human because this is an open loop system. The combination of the speedometer, the driver's eye, and the driver's brain forms the system's feedback loop. Excuse me. All right, so in this one, we've replaced our foot with the cruise control, all right? So if a car has an automatic speed control system, the driver is removed from the feedback loop. The speed is monitored automatically and is compared to the ideal speed set by the driver, or the desired speed. So our command input is set speed, right? I'm gonna set the speed. So I do that on my cruise control and adjust it. My car, built out of the 7 properties, creates an output of the actual speed. So my car is going 30 miles an hour. If a car has an automatic speed control system, the driver is removed from the feedback loop. The speed is monitored automatically and compared to the desired speed set by the driver. Again, the only flaw with this is the idea that cars do not slow themselves down as a result of cruise control. They will stop putting gas in the engine, but they will not actively apply the brakes. Okay, there are 3 major types of systems. There are technological systems, there are social systems, and there are environmental systems. And as you can see, they all overlap. Systems, which are building blocks of technology, are embedded within technological, social, and environmental systems. Any system that you see or know is, in theory, inside of one of these larger building blocks: technological systems, social systems, and environmental systems. Okay? All right, we're at the summary. System is a group, so this is our vocabulary word, is a group of interrelated components designed collectively to achieve a desired goal. Systems can be open loop or closed loop. Control of open loop systems often requires human intervention. A closed loop system is a control system that uses feedback, from the output to control the input. I need coffee. That is the way we think of control in a system. It is controlling the input and the output. So one thing that when I was talking with students that seemed a little confusing for them was the idea that an open loop system needs a human and a closed loop needs feedback. It's not really that way. That in defining it, an open loop system just has no feedback, and a closed loop system has feedback that allows the system to operate continuously. Okay? When I buy a spigot for my water line so I can have a hose outside, it does not come with a human to turn it on and off. That's up to me. But that makes it an open loop system. So systems thinking involves considering how every part of a system relates to others for a common purpose. Technological systems include input, processes, output, and at times feedback. A technology system is a combination of materials, devices, structures, information, and energy working together to solve problems and extend human capabilities. The universal systems model, our second word, is a general conceptualization, you could just say as a general concept, on how human design process can be represented. Is a general conceptualization on how a human design process can be represented. Systems thinking applies logic and creativity without compromises to complex real-life problems. Analyzing a system is done in terms of its individual parts or in terms of the whole system and how it interacts with or relates to other systems. Systems also appear in many aspects of daily life, such as solar systems, political systems, civil systems, school systems, and technological systems. Systems, which are building blocks of technology, are embedded within larger technological, social, and environmental systems. Life on Earth can be thought of as a complex web of interconnected, natural and man-made systems. Okay, I don't know why I have the yawns. I'm so sorry. Arrête, we are done. All right, so I have a little video to follow this up with, all right? It's only 2.5 minutes, but what I really like about it is that it lists for us a bunch of the 10 characteristics that an open loop system has and a closed loop does not have, or that a closed loop system has and an open loop system does not have. I think this just sort of crystallizes in your mind what these systems look like. How do they function? A closed loop system is much more expensive because it has a lot more moving parts. Open loop systems are relatively inexpensive and simple. Let's take a look.
That face that is usually covered by her phone has finally made an appearance. That face wouldn't.
Okay, are you seeing this full screen?
Yes.
Okay, perfect.
Welcome all to lecture series of mechatronics. This lecture is about what is difference between open loop and closed loop system. So first of all, see what is mean by open loop and closed loop system. Open loop system means output is dependent on input, but controlling action is totally independent of the changes in output. And now, closed loop system means controlling action is dependent on the changes in output. First difference between open loop and closed loop system is, in open loop system, feedback signal is not present, whether in closed loop system, feedback signal is present. Second difference is, open loop systems are less accurate. Closed loop system are more accurate. Third difference is, open loop systems are simple in construction. Closed loop system are complicated in construction. Fourth difference is, in open loop systems optimization in control is not possible. In closed loop system optimization in control is possible. Fifth difference is, open loop systems are easy for maintenance and having less cost. Closed loop system are difficult for maintenance and having more cost. Fifth difference is, open loop systems cannot compensate for disturbance. Closed loop system can compensate for disturbance. Examples of open loop systems are CD deck, digital thermometer, toaster machine, fan. Examples of closed loop system are automatic water level maintaining system, air conditioning system, robotic arms, CNC machines. Thank you for listening carefully.
There we go.
If you're a small or medium-sized manufacturer, you have big plans and big ambitions. ECI manufacturing.
Stop that. All right. I don't need components of a system yet. I wanted to show not the Kitty app. I swear I had this open. Let's get back in here. It's modules. I'm going to stop sharing, and I'm just going to read out some of these. I wanted to look at our homework assignment, having you think up an innovation that's going to cut 10 hours, turn a 10-hour job into a 1-hour job. All right. So let me get in here. Okay. Oh, I know what I need. Right. That's what I need. I'm going to go the other way around because I started at the bottom last time. Okay, so I'm just going to read out a couple. These are people's inventions that could perform a task 10 times faster. All right, I just think that the creativity is really wonderful. And a lot of people are a little stuck on the idea that You can think up any kind of invention your mind can conceive. I am letting you be the technological designer of this new invention. You don't care that these materials don't exist, the engineers can't find them, and you're asking to put diamonds in all the windows of your airplane. That's fine, because you're a technological designer, and it's up to the engineers to figure out how to make my design anyway. Okay, so a machine that I believe could cut work from 10 hours down to 1 hour is the plane. Today, planes seem very modern and practical, but still they could see major improvements. My invention, a self-flying plane with a faster speed, would be able to address many of the problems seen in modern planes. The aviation industry would benefit from this invention. It would shorten flights, making tickets cheap, which would in turn increase the number of passengers. Increased passengers would increase money, the money the airlines make. The speed make flying more practical and the best way to travel. The flight from London to New York is 6 hours now, would just be 2 hours in my new plane. What are benefits and costs? A benefit, the plane will be energy efficient. It will also use solar panels to power its engines. The plane will fly faster than present day planes, allowing faster, longer flights, making flying the most practical form of transportation. Those are great. What's an impact? Pilots might lose their job, which might spark hatred towards the new plane. This could either halt production because the airlines want to keep their pilots, or it could slow production. People might find self-piloting planes unsafe and don't want to fly on them. There could be malfunctions with the AI system that lead to crashes, getting you sued. This could hurt the aviation industry. Those are all great ideas, just great thinking. And you know what? Trying to just dream up consequences. Okay, there's another fast planes. Let me see. Oh, this is my favorite. Okay, a smart toilet. Whenever you need to flush, you could say, hey, Alexa, flush, and it'll flush the toilet. In case there's a clog, you could say, hey, Alexa, turn on clog mode, and it'll do some things to fix the clog without human assistance. Or you could even get the toilet to play music or project a YouTube video on your bathroom wall. I think we have been sorely neglecting our bathroom, and what a fabulous entertainment device our toilet could be. So what is a benefit or a cost of having a smart toilet? You could get your toilet fixed without having to call the plumber. That sounds good. You could get a toilet that projects YouTube videos for you. While you're hanging out doing your business, you got a little entertainment. Used to be the newspaper, so we're going into the 21st century. You could set a time where the smart toilet sprays Febreze in the bathroom so nothing would smell bad. Your toilet could have odorama. It could apply different scents depending on your mood. What's a negative? It could be really expensive. It wouldn't be able to clean the outside of the toilet, only the inside. It would take a ton of power to keep on and use all day long. I doubt that. I bet you could bring it down. I just thought that was thinking outside the box. I never thought about a smart toilet, but in this day of 5G, I'm sure my toilet is going to be on the internet, and I can probably get Pandora on my toilet. It's going to make, conversation at the water cooler very bizarre. How about self-checkout at grocery stores? What if that could be 10 times faster? What would that do? How would that impact us? Let's see. Now, these are not full sentences. I am hoping that you will give me full sentences. It would be cheaper. It would save time. It would make the size much smaller in terms of the checkout counter than a regular checkout. What are some impacts? You would probably lose some jobs of the checkers because the self-serve was so effective now. It would take energy and electricity. There would be a cost to running that machine. More people are able to steal and and fake scan an item since nobody is bagging the items for them. Nobody's watching you. How would you keep people from skipping steps? So the way they do that now is they actually weigh the bag and the product, and they know that that product should be arriving in the bag. But you can say things like, oh, I'm not bagging this item. Let's try one more. Okay. This one is a super fast laser printer to draw or copy things to paper. This would be very useful and time efficient for the public sector because it uses electricity and it would make it very easy to get your prints done. So some advantages. It could be used in government offices to make filing neater and faster. It could speed the time of government. Things could happen faster. You could get your permits faster. It could be used in post offices to make sending mail simpler. Education, industry can use it because they need to make lots of copies of lots of stuff. My job used to consist of standing in front of one of those giant copying machines, copying 50 to 100 different scripts for NBC television and putting in all the new pages. You had to manually put in page 33, page 52 and stuff to all those scripts. So I like the idea of an ultra fast printer. Also, that can print double-sided on legal paper without jamming. They always jam. Since it uses a laser, it might not be safe. It could use a lot of electricity to fuel the lasers. It might be expensive. Those are all legitimate negative aspects to this project. So if you haven't done one of these, please get that in. If you're in danger of failing, this should be fun. Dream up a product that's going to make the world better, that's going to do things faster for us. What was one, my favorite one was one that implants your classroom, your education in your mind while you sleep. I think that would make it 10 times faster to do your education, but I have to do some college hours, so I thought that would be a great idea. Whatever you can imagine. What are 3 of the benefits in full sentences? What are 3 of the problems? Just get that in. You can do it right now. All right, so that's Unit 2, Impacts of Technology in Society. Right now, we are going to have some time to work on our other project. Let me just read through. Now, of course, I'm not. There we are. I knew I had one open. So just to go over this one more time, what we're doing is the components of a system. This project is not due until the next quarter, the 17th. That means do not do this project if you are in danger of failing this interim. You need that other project or one of the ones before that because those are due in this time period. All our vocabulary tests, impacts and what was our last one? I can't even think. Let's go through the directions. Determine the components of a system, of a common communication system. The universal systems model includes the inputs, processes, outputs, and feedback. Identify the inputs, processes, outputs, and feedbacks within the systems given below. Then discuss how feedback is essential to the closed loop system. List the subsystems that might support the operation of the overall system. The definition at the bottom of the document could help. Look it up. It is subsystem. A subsystem is a self-contained system within a larger system, an independent system that supports the operation of a system. Okay? So the table in the table below, or if you had an incredible desire, you could put this in a slide, but just try and present this information. Describe at least one example of how to give how a given communication system uses the universal systems model. So you are being provided with an open loop system that is an automatic lawn sprinkler and a closed loop system that is a home furnace system. You are free to answer these questions about the automatic lawn sprinkler or the home furnace system. If you are interested in working on a different open loop or closed loop system, I have no problem with that. Pick the system that you feel you would like to talk about and drop it in there. I'm hoping you have enough experience now to be able to identify a closed loop system versus an open loop system. If you're confused, just send me an email and I'll help you to know, is that open or closed? All right. But my open loop system could be a water faucet, a light bulb, as it said, my CD player, an aerosol can. You know, let's just looking around. What else do I have that is a open loop system? My light bulbs, all that good stuff. So a closed loop system, a system that has feedback, is your home furnace system. What is here? Well, just to make sure nobody's sleeping, Aaron Main, what is the feedback system on a home furnace?
Maybe it's the person controlling the temperature.
No, what you don't get a person with your heating system. So in my house, while I'm asleep at 2 in the morning, what feedback system is telling my furnace when to turn on and when to turn off? It is not me.
Maybe the thermostat.
Right, exactly. And what's in a thermostat that allows it to have a feedback mechanism?
A thermometer.
Right, it's a thermometer with some way of telling if it's above 70 degrees, stop. If it's below 70 degrees, start. You know, it's probably in 1 degree increments. Once it hits 71, it kicks in and brings it back down. You know, I'm thinking of air conditioning. So once it goes down to 69, the furnace is going to kick in and raise the temperature to 70 and stop. It'll drop down to 69 and it'll go back to 70. For us as humans, it feels like it's staying at a pretty constant temperature. But that is the feedback system. What's interesting is in old thermostats, it was actually a mercury switch. It was a mercury switch that mercury slid across and completed the circuit when it was at the right temperature. Okay? So you can work on this. Our vocabulary test for systems and universal systems is also going to be due on the 17th. So that's all going into the next semester. So what you can work on is any past vocabulary tests that we have. What have we had so far? We have had 4 vocabulary tests, I believe. Let's get to quizzes. Where's my quizzes? There's my quizzes. So I believe we have had our unit, not that, we've had our week 1 vocabulary, week 2, week 3, and we are in week 4. So do your criteria and constraints. That has fabulous definitions. Get your impacts, get your impact of technology, individuals. No, that's not what we're doing. I'm sorry. So technological design, engineering design, and impacts and consequences. Those are your vocabs that are outstanding, I believe. So you can work on your systems project, on the inputs and outputs, and what are working in a closed or open loop system, or you can work on your past vocabs. All right? And I hate to say you only have 2 minutes. Okay, so just looking. At our stuff in this interim. We turned in our beverage labels at the start of this interim. If you have not done a beverage label, you could do that. That is our design challenge at the start. There are 4 vocabulary tests, 4 vocabulary quizzes. We also have our project with the good product and the bad product. How did advertising help those? So please get some things in as quick as you can. I need to be doing my grades this weekend. So if you don't have it in, I can't grade it. Help me help you. Okay, we are done. You may leave. Thank you. Great day.
Thank
Have
you.
a happy weekend.
Bye. Thank you.
Bye. Thank
Bye
you,
from the
Mr.
beautiful
Swift.
Carmel Estuary.
Bye, Mr. Swift.
Goodbye, Mectic.
Miss Janelli.
Ah,
Bye.
wow, you're looking good.
Thank you. It's my mom's birthday.
Wow. Yeah. Wish her a happy birthday for me.
I will. Thank you so much.
You bet. Nelson, Jackson, can I help you? Nelson? Dream? Dream, can I help you? I know we haven't spoken much, but Dream, Jackson, Nelson? Dream, I just want to know, I promised your grandmother that I'd touch base every 3 classes to let her know how you're doing. Dream, can you see that? Nelson, Jackson, Dream, you're all in that boat. I just need you to get a few assignments in. Can I help you? Can we go over it? Can we do it right now? I'll get you passing, I swear.